Okay, students, so let's go ahead and look at this example key for the building an atom simulation worksheet. I don't want to give you the answers and make you feel like these are the only correct ones. I just went through this and wanted to give you an example of what you may have gotten. Okay? So number 1 says add 1 proton to the nucleus of the atom within the simulation. What element did you just create? Notice that it's also highlighted on the periodic table to the right. So that would be hydrogen. Number 2, add another proton. What element do you have now? This would be helium. Number 3, keep adding protons. Describe any patterns you notice. So I notice that the element changes as you add protons. Click the reset button in the bottom right corner. Number 4, add 1 proton and 1 neutron to the nucleus. Which element did you create? This would be hydrogen again. Add another neutron. Which element did you create? This would be hydrogen still. Okay. Number 6, what changes when you add a second neutron? So I noticed that the mass number increased by 1. If you open up the mass portion on the right side of the simulation, you can see that. Number 7, keep adding protons and neutrons to the nucleus. Describe any patterns you notice. I noticed that protons determine the element and neutrons add mass. However, protons also add mass. Okay. Number 8, from the Show menu on the right, add a check mark by clicking the box next to the Stable, Unstable label. Using at least 4 protons, add neutrons and electrons to make a stable atom. What element did you create? How many protons, neutrons, and electrons does the atom have? Describe why you think it's stable. So I created beryllium. It has 4 protons, 5 neutrons, and 4 electrons. It's stable because there is some ratio of protons and neutrons that must be necessary. Alright, number 9. Now make an atom that is unstable. What element did you create? How many protons, neutrons, and electrons does it have? Describe why you think it's unstable. So I created carbon here with 6 protons, 5 neutrons, and 4 electrons. The ratio of protons and neutrons must be off here to create an unstable element. Alright, moving on to number 10. Describe what you think is meant by the term stable. Stable could mean that the atom is unreactive, maybe. Okay, we haven't talked about that yet, but it's possible. Click on the reset button. Add 1 proton to the nucleus. Add 1 electron. Describe what happens when you add it. Remove it again if you missed it. The electron creates a neutral atom. Number 12, add another electron. Describe what changes. It shows that it makes an ion. Number 13, add more electrons. What do you notice about where they are placed on the atom compared to the first 2? So it looks like the electrons are placed in the next orbit or circle after the first 2. Alright, number 14, add various amounts of protons, neutrons, and electrons. Determine any patterns you notice. How can you predict whether an ion is positive or negative? So a positive ion has more protons than electrons, and negative ions have more electrons than protons. So there's that ratio. 15. What do you think is meant by the term neutral? Maybe that there is no overall charge to the atom. Okay. Now, click on the reset button. Expand the net charge and mass number menus by clicking the green plus on the right side of the boxes. Change the numbers of protons, neutrons, and electrons and observe the effects of these changes on the net charge and mass number of the element. Answer the following questions after you've investigated what happens. Number 16. What variables are you manipulating in this exercise? Identify a symbol to represent each variable. So we are manipulating protons, neutrons, and electrons. The protons, I'm going to say, are P+. The neutrons are N naught, and the electrons are E-. Okay, number 17, using the symbols you just defined, write a math equation that explains how to calculate the mass number. So I see that the mass number is a result of the protons plus the neutrons. And number 18, using the symbols you defined, write a math equation that explains how to calculate the net charge. I see the net charge as being the result of the protons minus the electrons. Alright, we're making good progress here. At the bottom of the web page, open the symbol portion of the simulation by clicking on the symbol icon. You will use the simulation to figure out what each part of the symbol represents in an atom. Number 19. Place an amount of protons, neutrons, and electrons in the atom so that you have a neutral, stable atom with at least 5 protons. What element did you create? How many protons, neutrons, and electrons does the atom have? So I created boron here. It has 5 protons, 5 neutrons, and 5 electrons. Number 20. Explain what the letters in the middle of the card represent. So it looks like that would be the element symbol. Number 21, explain what the bottom left number represents. That would be the number of protons. Explain what the top left number represents. That would be the mass number, which is a result of the protons added to the neutrons. Number 23, explain what the top right number represents. That would be the net charge. Number 24, create a different ion. What number changes and why? So the top right number changes, and that is the result of the ratio of protons and electrons. Number 25, create an unstable atom. What number changes and why? So the top left number changes, and that's because the ratio of protons and neutrons. Okay, so that's finished with this. You can certainly play these games and test yourself with different things. If you have time, go ahead and do that. And let's look at the last page here. So the atomic theory. How can you predict which element an atom is based on the particles in its nucleus? The element identity is determined by the number of protons. Okay. Number 2, which particles have an effect on the mass of an atom? That would be the protons and neutrons within the nucleus. Number 3, why don't all of the particles in an atom contribute to the mass? The electrons do not. Okay, the electrons are the ones that do not contribute to the mass. Number 4, what particles affect the net charge of an atom? The protons and electrons affect the charge. Number 5, why don't all of the particles in an atom contribute to the charge? Well, that's because the neutrons do not have a charge. They are neutral. Number 6, which particles affect the stability of the nucleus? What is meant by stability? It looks like the protons and neutrons affect the stability of the nucleus. There must be a special ratio of protons and neutrons necessary. Okay, we'll get into that later. Number 7, in terms of its particles, when is an atom considered neutral? What is meant by neutral? The protons equal the electrons. Okay, so it would be neutral when the proton number is equal to the electron number. Neutral means that there is no overall net charge, no plus or minus. And lastly, does a given element always have the same number of each particle? Why or why not? using a periodic table, give some specific examples. So I said no. One example would be beryllium. Beryllium is stable with 4 protons and 5 neutrons. So there you have it. If you have any questions, please let me know.